Have you ever looked up at the night sky and wondered what's really going on out there? Beyond the familiar moon and the twinkling stars, there's a giant, a king of planets, swirling with storms bigger than our entire Earth. That's Jupiter. But what we see, those beautiful bands of cream and caramel, are just the top layer of its clouds. What secrets are hiding beneath them? Let's dive in and find out. For centuries, Jupiter was just a bright point of light. Even with early telescopes, we could only see its stripes and its great red spot. But we always knew there was more to the story. What's under that thick, swirling atmosphere? Is there a surface? Is there something solid at its core? These questions have puzzled astronomers for generations. Today, thanks to incredible missions like NASA's Juno spacecraft, we're finally starting to peel back the layers of this gas giant and get some answers. First, let's talk about those clouds. They're not like the fluffy water vapor clouds we have on Earth. Jupiter's uppermost clouds are made of frozen ammonia crystals. As we go deeper, the temperature and pressure skyrocket. The next layer is likely made of ammonium hydrosulfide, and below that, clouds of water ice and vapor. Imagine flying through a layered cake of chemicals, each layer with its own storms and winds, all at a scale that's hard to even comprehend. And the winds on Jupiter? They are absolutely wild. We're talking speeds of over 400 miles per hour or 640 kilometers per hour. These winds aren't just on the surface, they run deep. Juno discovered that these jet streams, which create Jupiter's famous stripes, plunge at least 3,000 kilometers, or about 1,100 miles, into the planet. That's like having a hurricane that's as deep as the distance from Los Angeles to Chicago. This tells us that the weather on Jupiter isn't just a surface phenomenon, it's a deep-seated part of the planet's very structure. Now let's talk about the most famous feature on Jupiter, the Great Red Spot. This isn't just a storm, it's a superstorm, a gigantic vortex wider than our entire planet that has been raging for at least 350 years. For the longest time, we didn't know how deep it went. Was it just a thin feature floating on top or something more? Juno's recent flyovers have given us a stunning answer. The Great Red Spot is not shallow at all. Its roots extend more than 300 kilometers or 200 miles into the atmosphere. That's 50 times deeper than Earth's deepest ocean. This depth helps explain why it's been so persistent, drawing energy from the planet's interior heat. But what about lightning? With all those storms, you'd expect some. And you'd be right, but Jupiter's lightning is not what we expected. On Earth, lightning is most common near the equator. On Jupiter, it's the opposite. We see most of the lightning flashes near the poles. The theory is that the sun's heat warms Jupiter's equator, which stabilizes the upper atmosphere and prevents the formation of the tall, convective clouds needed for lightning. At the poles, however, that stability is gone, allowing warm gases from deep inside to rise, creating massive thunderstorms and what scientists call shallow lightning. It's an upside-down, inside-out version of what happens on our own world. So we've gone through clouds, winds, and storms. What happens if we keep going deeper? The pressure becomes so intense, so crushing, that the very nature of matter begins to change. About a quarter of the way into the planet, the hydrogen gas that makes up most of Jupiter gets squeezed so hard that its electrons are stripped away. It stops being a gas and becomes something else entirely, a liquid metal. Imagine an ocean, not of water, but of metallic hydrogen. This swirling, electrically conductive ocean is the source of Jupiter's immense magnetic field, the most powerful of any planet in our solar system. It's nearly 20,000 times stronger than Earth's and creates a vast magnetosphere that traps charged particles, creating intense radiation belts that would be incredibly hazardous for any unprotected spacecraft or human. This metallic hydrogen ocean is one of the biggest secrets Jupiter has been hiding, a state of matter that we can barely create in labs on Earth, but that exists on a planetary scale. So we've reached this bizarre metallic ocean. What's at the very center? This is one of the most hotly debated questions in planetary science. For a long time, the leading theory was that Jupiter had a small, solid, rocky core, maybe 10 to 15 times the mass of Earth, which formed first and then attracted all the gas. It was a neat and tidy model. But Jupiter, as always, had a surprise for us. Juno's data suggests that Jupiter's core isn't small and solid at all. Instead, it seems to be fuzzy or dilute. The heavy elements like rock and ice aren't packed tightly in the center. Instead, they're mixed in with the metallic hydrogen, forming a blurry, extended core that might stretch out to nearly half the planet's radius. How did this happen? One dramatic theory is that early in its history, Jupiter was hit by a massive protoplanet, a planet in the making about 10 times the mass of Earth. This colossal impact would have shattered Jupiter's original core, scattering its contents and creating the fuzzy, mixed-up center we see evidence for today. It's a reminder that the early solar system was a chaotic, violent place. So to recap the journey, we start in the icy ammonia clouds, dive through layers of different chemical storms, brave hurricane winds that plunge thousands of kilometers deep, witness lightning at the poles, pass through an atmosphere that becomes a sea of liquid metal, and finally arrive at a bizarre fuzzy core that was possibly shattered by a cosmic collision. Every new piece of data from missions like Juno rewrites our understanding of how giant planets form and evolve, not just in our solar system, but around other stars too. Jupiter isn't just a planet. It's a laboratory for extreme physics, a place where the rules of chemistry and meteorology are taken to their absolute limits. The secrets beneath its clouds tell a story of immense scale, incredible power, and a violent, chaotic past. And the best part is, we're still listening. The Juno spacecraft is continuing its mission, looping around Jupiter, getting closer with each pass, and sending back information that helps us refine our theories and ask new, even more exciting questions. What other surprises does the King of Planets have in store for us? We'll have to wait and see. Thanks so much for joining me on this deep dive into Jupiter. It's just incredible what we're learning about our cosmic neighborhood. If you found this as fascinating as I do, please hit that like button and subscribe for more adventures into the mysteries of space. Let me know in the comments what you think is the wildest thing about Jupiter. Until next time, keep looking up.